All right, so let's get started. I think we have 31 of us are here, and we can just begin. It would be nice if we all get a class on time, but I know it's early in the morning for you, so I guess okay. Anyway, from last time, if you remember, we started MongoDB, and we essentially looked at a lot of the operations that we need to do CRUD. And you all know that CRUD is create, read, update, delete. And these are like the basic operations that you might want to execute against the data store. And yeah, we also realized that the MongoDB API is fairly intuitive, beginning with how do you create a database? And in fact, we said the way to do that is using the use keyword right here. And this would also switch the database anyway, if you've created it before. So it doesn't matter if you're trying to select a database or you're trying to create a new one. You're simply saying, this is what I want to use. And if it exists, it would pick it up. And if it doesn't exist, it would create a new one. So that's how you think about it. I want to use this database. So if it doesn't exist, please create it. This is what this means. And this command show DBs would enumerate all of the databases that in fact you have. And db.create collection, this is how we create collection inside of our database. And once we have a collection created, then we can run a bunch of operations against that collection, beginning with insertion operations, which is creating documents or records inside of the collection. We could also read from the collection with find. And we could also find using different filters, if you will, right? So we can have different match predicates that we can use to find documents or records inside of our collection. So in this case, we wanted to find if only collections or data records where student ID is defined. And we use this to demonstrate the fact that every attribute allows sometimes functions to operate on it, right? In this case, there is a student ID, which this is data attribute of choice, and then we can check if it of course exists. But this is not the only way to filter down our data, right? We could filter down based on if the ID is greater than a value or less than a value. In this case, we could also match explicitly based on a particular value. And in fact, we did that here. So we also, what did we do? Okay, we also learned that we could do projection, right? We could turn on or turn off data elements in our result set. So in this case, we were turning on first name and gender. And whenever those attributes exist, they would be the only things returned. And we also showed that the ID is returned by default. And if you don't want to turn on the ID, you have to set it to 0 in your projection. So we showed last time that define function, which over a collection takes two parameters, right? The first one is being able to filter down the data using some kind of match predicate or match condition, if you will. And the second parameter it accepts is this projection, right? Where you can turn on and off elements in the data so you can simplify or reduce your feature space. All right, so those are the two parameters that the find function takes. First one is the where clause, if you will, in SQL, or the match condition. The second one is the SQL projection, where you turn on and off data elements in your results set. Then after we did that, we were able to update, right? We went to update a single record, and where we provided a match predicate, and we also have our set function, right? It is canonical that when you're updating a record, you are setting something on the record. And in our case, we could not only change the value of a property that already existed, we can also attach the value if we want, right? So when you look at this set function, if you will, it sets first name to Becky. So if first name doesn't exist, it will just attach that property to the record and then set the value to Becky. And if the property existed, it will just change the value to Becky in this case, right? And then after we did that, we tried that a few times just to reinforce the point. And we performed a series of Morse SQL projections. And then we decided to show how to use the insert many function. With the insert many function, you can provide an array of documents, and a document is a JSON object, right? By JSON, we mean JavaScript object notation. So this is a JSON object. For those of you who are familiar with JavaScript, you already know how to compose object in this way, right? So you have the property, and then you have the value, you have the property, and you have the value, like so. And at the end of the object, you have a curly bracket, right? And then you have a comma, and then you can specify another object like so, and you can insert many. So it's a series of objects can be inserted in this way. And the other thing we demonstrated is that the objects don't have to have the same attributes, right? In this insertion of insert many, you can see that the first object has a number of attributes, and the second object that we inserted only has one attribute, right? Student ID equals to 3. So you can have an irregular shape in your insert many. So an array can contain objects that have an irregular shape. They can have properties in common, or they can have nothing in common. It doesn't really matter. And so we're able to do the insert many. And as usual, we operate the find, which is a function over a collection of students. And then, we also demonstrated how we could use the update one to attach a number of properties to the student that we created here. So we were able to match on student ID 3, and then we attached this property, first name and last name, so that the document or the record is more fully fleshed out. And then we went to update many, and we said that updating many is, in fact, only useful if you are updating many in groups, right? If you're trying to set a property that belongs to a group of students, then update many would be quite frankly useful. So imagine that instead of, I said, when student ID is greater than 0, I want to update everything. You could also say that, if the height is greater than 6'2", then I want to update basketball team to true or something like that. So update many is something you have to use when your match predicate, or your query, if you will, or your match or your where clause using SQL terminology, is able to kind of reduce the amount of data that would be affected to precisely what you want, right? So you reduce the data space to the subset that you're interested in, and then you can set the attributes on all of them, right? So it's important to get the match predicate correctly, right? When you're running update many. And then we realized that we could also do delete many. And when you delete many, you provide a match predicate, and it will just delete all of the data that matches the predicate. And in the same way, in the same way, we could delete one as well. So I don't think we actually tried delete one. So maybe that's where we should start from. We would delete one. And there was a question last time on how do you rename a field or an attribute field or a property name. For example, this is an attribute name in this document or in this record. Last name is also an attribute. How do you rename it? Imagine that you spelled it incorrectly. You don't want to delete the data and recreate it. Could you rename it? Right. So we'll do that as well. Okay. So just as a refresher, I would begin with delete one. By the way, if, a way to CLS is clear the screen. So if you execute that, it would give you like a fresh cursor on top of the page, but your old queries are not gone. In fact, if you try to scroll up, you should or scroll down, you should find it. So CLS is just a way to kind of give you a brand new page, and in this case, this is what I want. All right, so as usual, we will have db.students. Because I'm already in BA64. If you're not in BA64, you have to begin by typing use BA64, okay? Because that's what we did last time. You have to do use BA64 to select the database, and then you'll be ready to execute queries against the collection in the database. So to see what you have, you can type show collections. You can see that we have students. So I would reference this with db.students. So now I'm referencing my students collection. And on this, I want to, first of all, I want to find which enumerates the data that I have there. And I want to delete one of them. In fact, I want to delete this record or this document with student ID 3. So delete one, which we didn't do last time. Dot delete one. And again, we know this is camel notation. The function will begin with a small letter, and then the boundary of the next word will be capital letter, like so. And delete one, we take a document from me, which is it's going to use to match the record that I want to delete. And I'm interested in deleting student ID 3. And you can see that I have gotten the acknowledgement, and my deleted count is equals to 1. And now if I run my find function again, I only have one record here. So, but imagine that I want to change it in CM or weight in pounds to actually be weight in pounds, not LBS, which is the short form for pounds. How would I do that? How would I be able to do that? There was a question about this last time. And so I think it's important for us to maybe address that. But I would say that it makes sense that we would be doing this, right, inside of the update function, right? Because we're trying to update something, only that instead of setting something, what we would like to do is rename. So, and that's precisely what we would do. So, depending on whether or not, if you're trying to rename a property, it makes sense that you're updating many, not update one. So we would again go to db.students.update many, right? Which I think makes the most sense. And then you have to provide a match predicate, which we don't care about at all in this case. So what we want to do here is we want to rename, right? And this is going to take a document from us. And the document, of course, would be what are we renaming and what are we renaming it to, right? So we want to rename weight in pounds to weight and you can see that it acknowledged it and it matched one thing and modified one thing. And now if I run my find function as usual, you can see that my weight in pounds has now been renamed to weight in pounds, which is what I want. So yeah, so this is a direct answer to the question from last time. When you're trying to rename, the only thing that changes is you rename. Because set is for either attaching a property or changing the value, right? So yeah. So in that sense, this rename allows you to modify the property itself to change it from one form to the other. But if you in fact want to change this on one thing, then you could essentially change this query from update many to update one, and it would work, right? Update one. But if I'm going to update one, it makes sense that I identify the one that I want, and I would have to, in my match predicate, I would say that I am only interested in student ID of one, right? So it's going to match that. And since I've already changed this to weight in pounds, I can change it back to what it was before. So, and this would be weight in, yeah, it would be weight in pounds, but the short form, like so. And this would also work, only that this time this targets one record, one document instead of the entire thing. So, and if we run our find function again, you will find that this has been renamed back from weight in pounds to weight in pounds. So, all right, excellent. So today I would actually take a break from, well, before I take a break from just typing a bunch of code and talking about the aggregation pipeline, which I would do with a slide, and then I would type the code. Let's talk about function composition, right? Function composition in MongoDB. So let's do that. All right. I think I need to reshare my screen. I apologize. My screen sharing somehow stopped working. All right. Okay. So function composition in MongoDB. So what do I mean by this? So imagine that there is something called commutative functions, or commutativity. So what does this mean? Well, it means that, for example, A and B are commutative under some operation, under some binary operation. A binary operation is an operation that takes two terms, right? Let me define that for you. A binary operation is an operation that takes two terms. Takes two terms. So binary in that sense. If A operation B is the same as B operation A. So if this is true, then they are commutative. Spell it wrong, commutative. right? So this is an important notion. So, and I will explain what I mean by this after I talk some more about, yeah. So for example, maybe this is not, that's not an example. And now this is an example. For example, 2 plus 3 is the same as 3 plus 2. So we could say then, that 2 and 3 are commutative under addition, right? Everyone agrees with the statement, right? That 2 and 3 are commutative under addition because 2 plus 3 is the same as 3 plus 2. Everyone agrees? If you agree, can you raise your hand? So I'm trying to check how many people are following the lecture. All right, good enough. You can put your hand down. All right, so when I am talking about function composition, in my mind, I have an idea like this, right? So I can say then that two functions are commutative if f of g of two functions, f and g, are commutative if, right, f of g of x is the same as g of f of x, right? Assuming x is the input. So we're extending this idea of commutativity, or two things being commutative, to functions. So two functions are commutative if f of g of x is the same thing as g of f of x. So if the arrangement doesn't matter, that's all we're saying. It's a big word for saying if the arrangement of the function, the position of the function, doesn't matter which one you do first, right? If it doesn't matter, the answer is the same, then we say they are commutative. It doesn't matter if 2 comes first or 3 comes first. Under addition, if you're adding 2 to 3, you're always going to get 5. So if we're saying that two functions therefore are commutative, if f of g of x is the same thing as g of f of x, if it doesn't matter the order in which you compose the functions. So, and the other thing I want to talk about is this is now a composition of functions, right? My input gets passed to a function g, and the result of g of x gets passed to f. And so now I have this composition, if you will. So strictly speaking, I could say that f of g, right, these two functions composed together of x, which is my input, is the same as g composed with f, if you will, of x, right? So you've kind of chained the functions together, if you will, and I'm going somewhere with this in MongoDB, right? So now let's add some more. Let's add some more data elements. So I'm going to copy this. Now change this to Ruth. And I will change the item centimeters to 160, and I will get rid of the other document. Instead, I will try to copy this, and then I will try to paste it here. And I would change this to 162 and change this to Jones and this to Mike and gender to male. All right, so now I have more data in my collection. So I have 3 documents in my collection. And so the first I would like to show you is this function called skip, right? So now I have done this. I have done .find .skip, right? Now so this intuitively makes sense because it skips the number that I specified here, right? And it returns whatever is left. And in this case, since I only have one function, one data attribute left, or document left, it returns that. So, but what we would like to do is sort, right? We would like to sort in some kind of reverse order, and we would like to see how that would work. And then we will now begin to see how this idea of composition works. So sort. I think we can sort and we can pass I think we can just do this. I'm not sure. If it doesn't work, okay. Let us see how sort works in MongoDB. All right, so we know that all right, so precisely we can do it this way. Okay. Of course it makes sense, and what I did before doesn't make sense. So let's pick a data attribute that we want to use for our sort. So it's going to be student ID. Student ID, and we want to sort this in reverse order. And hopefully this works. Sort direction doesn't work. Oh, yeah. The problem is not that. The problem, see, I think is incorrect. Let's do it this way, and let's hope it works. All right, so finally, I got it to work. Okay, so this just sorts it sorts by student ID, right? And clearly we have two student ID having the same value. We don't want this, so let's update this. db.students dot update one, and we're gonna match on first name since that's pretty easy. And that's going to be Mike. And we want to set student ID 23. And it should work. And now let's go find and sort. So we're sorting this in ascending order based on student ID, but we can also sort in reverse, right? Which is where I started from -1. And you can see now it's sorting in descending order. So student ID is 3, 2, 1, right? So now back to composition. So I'm going to sort. I'm going to skip. I'm going to skip 1. So the question is if I should move the skip forward and then sort after. Does this change my result? Does it change my result? Is this function commutative in some sense? Okay, so let's go try it. So let's skip first, and then we'll sort after the fact. So we'll skip 1, and then we will sort. So you see that the result is identical, right? So it doesn't matter whether we skip 1 and then we sort later on. The interaction of this function when you chain them together is they're commutative, right? So fg of x is the same thing as gf of x, right? So you have this interesting commutative function composition that you can achieve, if you will, in MongoDB. So you chain two functions together and you pass an input and you reverse the other, you would get the same response. It doesn't really matter how you compose it, right? So you have commutative function compositions, is what I was trying to kind of show. So when you sort and you skip or you sort, you end up with the same thing. So it doesn't really matter how you do it. So let's do something else, right? So let's limit our, remember how in SQL, we could do we can select top 1 from students like this. Let's just look at the first one. Oh, it's an ID. First name. All right. And you can see that it brought back 2 and Philip. So let's just bring in the last name. So we have more to show. Now we have Philip Morris. So if I want to top 3, and now I have top 3. If I want top 4, now I have top 4. So the question is, how do you do this in MongoDB? Well, there is a limit function that allows you to do that. So you can limit 1, and you can see that it returns the first one alone. If you limit 2, then it will return top 2. See, top 2. And if you have a limit of 3, it would return top 3, and which is everything we have anyway, right? So now you can now think about composition in this case. Imagine you attach a sort to this. What happens if you limit 1 and then you sort by string ID -1? So you can see that the sort is in the reverse direction, and the limit is 1, the first one, and in fact this is what happened. So, and if you write it with the sort first and then the limit after, you would see that you would get the exact same result as well. So you have this commutative function composition, limit of 1, and here we go, the exact same result. So it doesn't really matter how we write it, whether it's limit sort limit, we are guaranteed that the result would be the same because of this commutative function composition. And this is implemented in MongoDB in a way we don't really care, but for us, on a very abstract way, mathematically, there is a guarantee that these functions are in some sense commutative, at least when you are running them against the find operator, right? So when you're running them against the find, or you're chaining them to the find, you're guaranteed some kind of commutativity in the behavior of the functions that you chain. So so what happens if we do this and then we skip 1? What can we expect from this? You know, of course we expect that it will go straight to 2. And what happens if we, you know, if we did the limit first, we sort second, and then we skip 1 thought? And in fact, you can see that the result is the same. So could something else maybe happen if we should move the skip to the second position and then do the limit after? So let's try that. So we'll skip 1 and then we'll limit 1. And we'll see if, in fact, this guarantee works completely or there is a limitation. But you can see that it doesn't really matter how you do it, how you compose the function. You know, this function in some sense is not just commutative, is also associative. And this brings me to my second point. So there is also something called associativity, which means that under a binary operation, like so, this is just a representation of some operation, abstract. A, comma B, comma C are associative if and only if the following holds. If and only if the following holds. If A operation, binary operation B, right? So you do that first. Don't forget it's a binary operation, so you can only do it 2 at a time. You get the result of this, and then you compose this. You apply this to C. It's the same thing as A, binary operation, you do B and C first. So B, binary operation, C, like so. So when this holds, then we say that the binary operation is associative under any three elements, right? So for example, under addition, we could say that A plus B plus C, like so. So you do these two first, right? In fact, let's do 2 plus 3, right? Which is 5 plus 3 plus 4, right? Or in fact, let's make this 5. Is the same as if I did 3. Sorry, if it's the same as if I did 5, 3, and 5 first, right? And then 2. Because we know that under any of you knows what BODMAS or PEMDAS stands for BODMAS. Does anyone know what this stands for? Nobody? You've never heard of this BODMAS or PEMDAS? So if you don't know what it stands for, before I allow Jessica to tell us the answer, if you don't know what it stands for, can you raise your hand? You don't know it. Okay, it's okay. I just want to make sure you're paying attention, because if you're paying attention and you don't know it, that's fine. All right, you can put down your hand now. And Jessica will tell us what it stands for. So what is BODMAS or PEMDAS?
First, for the PEMDAS is the parentheses, exponents, multiplications, divisions, additions, and subtractions.
Right. So
And
what is that?
and those is like the reminder for the order of operations in the
Exactly.
mathematics.
Exactly. So precedence or order of operation, which one do you do first, right? Imagine that I have this, if I give you this equation, right? 2 plus 3 times 4 divided by, okay, minus 5. Let's do it this way. I want it to be easy, but I will put it in bracket. So what's the answer to this question, right? To do it, you use BODMAS, which just tells you which one you would do first. This is the British way of doing it, so it means the same thing. It just means B means bracket, but in the American way it means parenthesis. So this is it. This is bracket and this is also parenthesis. It's the same symbol. So the way you would do this is that you would do this first because it's what's in the bracket or parenthesis. So you would first of all reduce this to 2 plus 3 times 2, right? So now you have done the bracket first, and BODMAS says that before you can do addition, you have to do multiplication. The same thing for PEMDAS as well. So you now have to go, your next line would be what? Would be 2 plus 6. And now we know the answer to this problem. The correct answer is 8. According to BODMAS or PEMDAS, the correct answer to this problem is 8. And the way you determine that is this precedence or order of operators or operations. Thank you, Jessica. I am going to give you +2 for that. So I type in the message because you can go back and check what points, what free points you got later on. Just to all right. So why did I say this? I just wanted you to know that every time I put something in bracket, that's what you do first, right? So you first of all do, oh, I was going to get rid of this. You do what is in bracket, and then you apply the operation to the other parameter. So it's a binary operation, meaning it takes two terms. So that necessarily means that you have to do them 2 by 2. So this is the reason for the bracket. So associativity means that it doesn't matter which two we do first. The answer will be the same. So if we do this two first, it's the same as if we did this two first, right? So a binary operator takes two terms or takes two parameters at a time. So when you have three terms, it doesn't matter which two you do first, right? And when it doesn't matter which two you do first, then we say that it is associative, right? So it is the operation is associative on the set, right? And of course, addition is associative under the set of natural numbers or positive integers, right? So because when we have natural numbers, it doesn't matter and which two we do first. If we're doing addition, we're going to get the same answer. And so if you take a look at this MongoDB, and now that we have three functions, right, you see that we can extend this in the same way. So similarly, we can extend this notion to functions. Any three functions, f, g, and h are associative if and only if f composition G composition H is the same as F composition G composition H. So more explicitly, if there is an input X, then we expect that this composition of will be equal to F composition, this composition happening first of X. Like this should produce the same result, right? So and when you look at the MongoDB example, this is in fact the case. So it doesn't really matter which two we do first. We get the same result. So you can see that over the once you define function over a set over a collection in MongoDB, then any other function you execute is both commutative and associative, right? So it doesn't matter when there is two functions that you define, then it doesn't matter. The order doesn't matter at all, right? So it doesn't matter which one you do first, right? And yeah. So the order doesn't matter, right? So for two functions, for three functions, so both commutative and associative, the order doesn't matter, and so this is a very nice mathematical property that we can observe in MongoDB. Okay, so any questions? And then we can take a 10-minute break if you agree, and then we can come back at 8:10, and then I can start talking about the aggregation pipeline. Or if you guys are a bit tired, I can bring forward enterprise installation of MongoDB, and maybe next week we can do aggregation functions. So what do you want to do first? So do you want a lecture, or do you want to go straight to the aggregation pipeline? Either way, we have to talk about the enterprise installation of MongoDB, but I don't know which one you prefer. So if you want more time to practice some of these things, then I can use the rest of the class to talk about how we install MongoDB in an enterprise software domain, or I can move straight to the aggregation pipeline, which is how do we perform more high-level functions in MongoDB. So which one do you want? So I don't know how to take a poll in the Teams. Could take a poll. Okay, so I was going to take a poll, but I don't think it's working for me. This, but it looks like we want a discussion first. So I tried the poll thing. I don't think it worked. All right. Okay. So do we have any questions so far, though, before we go for our 10-minute break? And when we come back, we will discuss enterprise installation of MongoDB. All right. So I think I was able to get the poll. So please vote for what you want, and we would do the winning we would do the winning option. So let's take 10 or 15 minutes break, and yeah. Okay. I would see you at 8:15. All right, welcome back. So we are going to continue with MongoDB aggregation framework. So about 13 of you didn't vote. Next time give out a poll, I would also give out 3 points. So if you don't vote, well, you would be you're going to be missing the points. So, and also if you don't participate in the class and something goes wrong, I'm not going to listen to you either because I know you don't participate in the class. So think about it when next time you decide to not vote. MongoDB aggregation framework is what we decided to do. So the idea of aggregation is essentially derived from the word aggregate, which is to be able to collect data systematically in a way. So this is a framework for systematic data collection and processing, if you will. So first of all, there is this slide from MongoDB themselves, and this is comparing the scalability and performance of Memcache. I don't know if any of you know what that is. It's a very fast data store. And then under that, you have the key value stores, which are dictionaries that are stored and also distributed across multiple servers. So MongoDB performs nearly as well as those. And you can see that right under here, you have your relational databases like SQL Server, not performing as well. But here you see that there is more functionality, of course, in the RDBMS, even though it doesn't scale easily and it doesn't perform as well in terms of read-write throughput. So this is the performance criteria that we're using to measure them. And so RDBMS has the worst read-write throughput, but has a deeper functionality than any of this. In terms of read-write performance, MongoDB is just as good as any key value store, according to their claim, but they have also deeper functionality than key value store. All right, so all of this you've already seen before. I've demonstrated our queries work in MongoDB. So we know this select star from users essentially is equivalent to a find function over the users collection. And we know how to use the greater than and the less than in tandem with a particular data attribute of choice to further filter our data. All right, so I would skip this discussion on MapReduce because I would it might be complicated. So an introduction to the aggregation framework is that it's very declarative. You don't need to write any JavaScript. The framework itself is written in C++, as you can see, and it uses expression evaluation, so it returns computed values. So because it has an expression tree under the cover, right? So you have this beautiful consequence of being able to chain functions together, and then it will create an expression tree, and then it can be evaluated together. So this way, sometimes if things are done well, it will be easy for you to be able to have properties like commutativity and associativity kind of implemented, because you already have the idea of evaluating expression trees. And once that's done, then you would return the calculated value. So yeah, and the aggregation framework continues to grow and expose new functionality, but we are only going to look at the basic things that you can do. And beginning with being able to filter data, which we can already do very well outside of the aggregation framework. We can do the projection, which I will show you how to do, which the aggregation framework. It will be our simple example, our simple kind of introduction to the aggregation framework. We can unwind the data and yeah, so it's a nice function to unwind something. But it would have to be shown for you to really see what's going on here. So you know what group means. It's to create groups from the data, and to sort is to arrange, and to limit is to reduce the data based on a number. So usually you would select from the top. This is similar to the select top n, right, in SQL. So that's the limit function. And we've already demonstrated sort and limit, and you know how to filter. You also know how to project using the find function. The two things that you don't know how to do yet is to unwind and to group. But yeah, we'll take it one step at a time. Okay, so let's kind of get out of this PowerPoint, and let's see how we would use the aggregation pipeline over a collection. All right, so we're back to our Mongo shell, and we have a collection of students, which is what we have been working against. And it turns out that every MongoDB collection supports this thing called aggregate, which is your aggregation pipeline. And our very first kind of gentle introduction to the aggregation pipeline would be to essentially return all of this, but do a projection, just like we do with the find. With the find, we would project in this way. We would find, and we would pass in an empty document to say that we want everything. And then the next thing we pass here would be used to project. So underscore ID, we can say 0, so it doesn't come back. And we could say we want the first name. And we have already demonstrated that this would reduce our feature space to only be what we turned on, and that the ID is turned on by default, so we have to actually make an effort to turn it off with the 0. So how can we do something like this? Some of the same similar thing, but now with the aggregation pipeline, which has a bit more power and exposes more functionality. So, well, it will be db students dot aggregate like we saw in the slide. So which takes a general document, right? So one thing that you would see is in MongoDB, you always have these functions, right, taking documents, but the aggregation pipeline itself takes a document, and in this document, you can specify all of the operations that you would like to perform. For instance, we're dealing with this, whether you want to filter, you want to project, you want to unwind, group, sort, or limit, you can kind of list all of them inside of that document. Just say, and there it would take all of your instructions together and try to execute it cohesively, right? This is what it means when it says it does expression evaluation. So it almost tries to generate an expression tree from a document of operations that you want to perform against the collection, and then you get computed values back. All right, so let's go and see what that looks like. So this is my document, and in this document, I could organize, if you will, of functions and operations that I would like to perform. In this case, I'm only interested in one, right? I want to project, right? So right away, you can kind of see the benefit of this over the find function, because this is a bit more clear in terms of readability. When someone sees this, they know precisely what I am trying to do. Whereas in this function right here, it's really unclear what this does. Okay, you know that I'm finding something, and then I have passed in this stuff, and it's almost like magic. Some kind of, you know it because you're familiar with MongoDB. But if you have no interest in running the code, and you're just looking at the code to understand the code, this is really not the best way, because it's unclear what is going on here. There is nowhere here that I said that I am doing a projection, but right here in the aggregation pipeline, it's more readable. Even when you don't know MongoDB or you don't know how to write it, you have an idea of what is going on. You know that a projection is about to happen. So even though, of course, I provide the exact same document here, I'm going to do that, provide the exact same document and first name, 1. And we get the exact same result, right? In this and this is now producing identical result, but this is by far more readable than this. So, and this is not the only thing that I could do, right? It's possible for me to, for instance, say, let's just so in this main document, I have already specified one function. Could I specify another function? Right? Could I do that? Could I do something like this? Right? Is this allowed? Might not be doing this well. All right, I missed the yeah, bracket here. Okay, so I don't know why this is not working. All right, let's try this. Okay. Yeah, it's not clear what was going on there. All right, so let's try something else. Okay, yeah, I probably missed something and I didn't see it. So, but it seems to be working again. So let me go back to what I was doing. All right, so what we know for sure is that we could have a set of operations that we want to do. In fact, let's show that right now, which is what I was trying to do. And so let's sort first inside of our regression pipeline, and we will sort with student ID as usual. And then we want to project this would like to turn off the ID like so. I don't know if this is working, if I got all of the Oh, I'm sorry. I know what's going on now. Yeah. The curly brackets is not. I missed it. I didn't close. I didn't
dịch
close
vụ
the.
về lý chẳng hạn. Điều này ở đấy là chỉ để đó.
I didn't close the curly brackets. I was wondering what was going on. Okay. I didn't close the curly brackets for that operation, and I started the next operation before closing the curly bracket for the previous operation. So it keeps getting confused what's going on. All right, so it is part of the disadvantage of using the IDE is too many curly brackets. It's unclear what's going on, and now it's working, right? Only difference is now I successfully closed the curly bracket for the first operation and then opened the curly bracket for the second operation. If you look at this one, I forgot to terminate it, yeah, and I just started another one, right? So, yeah, so that's, yeah, so that it doesn't like that. So you have to make sure within the aggregation pipeline that every operation has its own boundary and its own document, and that's how it likes it. And you separate it with the comma, and that was there in this case, but the boundary for the operation was not there. And okay, so now life is easy, and we're back again. All right, so you can see that I have turned off the IDE, and none of these attributes have the IDE, whereas before you can see the IDE was coming back, and now they don't have the IDE. And this is almost similar to what I am doing with the find, only that now I am just chaining all of this. I'm chaining all of this functions together by just listing them, right? By just listing them, so that if I open another one and I said dollar, let's say limit, for instance, which I think I already tried, and let's do this, and now you can see that it just kind of works. And we could maybe even unwind our student ID, and we will still get to that later on. And so this is how we do this. And life is easy. So the main point here is you could have anything listed, right? I could go here and let's change the limit to 1 or maybe limit to 2. But I could also, right here before my unwind, I could skip, right? I could skip here and I could skip 1 and it will be fine. And that would not work because the curly brackets again. And now you can see that now I have all these operations all just listed and it's just working. So now I'm able to demonstrate what I really want to show you as a trivial example for the aggregation pipeline is that you can have all of the functions just listed, and you can put everything in the aggregation pipeline and it would work, right? And in fact, let's start again and see if we can do everything that we've learned before with the aggregation pipeline without having to worry. And okay, so this is our first document. And here we're going to filter. And this filter is going to take another function greater than, right? Okay, so let's see if we did we close everything. So no, we did not. So and now it should work. So the idea is student ID greater than 0. Let's see if that that didn't work. So let's look at our stage. Okay, so that doesn't seem to be all right. According to MongoDB, it's supposed to be valid. So we will just we would run something else. We would do something like this. And still doesn't run it. So this is not compatible with this version for some reason, but this is not what we would like to do anyway. So let's move forward. Let's move away from we can easily do the filter function with defined, but except they changed the name, which I did not see. It should just work. It's well defined and the all right, okay, I'm not using it correctly. This is how we may do it. And let's see if there's a simple way to show this. Right, okay, understood. So this is not supported like in this form anymore. So this is supported in conjunction with a projection. So yeah, we would do that later. Okay, let's go forward and let's see how we can group things, right? How can we group a student by gender, right? How can we do that in MongoDB? That's a more useful operation. So to do this, the first thing we would like to do, of course, is to provide a document like so, and then you guessed it, there is going to be group. And for the group to work, you have to specify two things. One is the attribute that you are trying to you're trying to reference, and so which in our case would be kind of gender. So let's do that this way. And the next thing we would like to do is essentially create a kind of a bucket or an array, right? So we would say we can call it students, right? Since that's what we're operating over. Or we can have maybe student list, something like that, or student group, time annotation. So it's an alias. And what we would like to do here is we would like to, every time we find a new gender, we would like to add to set, right? So like meaning that it's going to create a set for us, and it's essentially going to add whatever attributes that we select from the list of attributes, and it would create a subset and would create it for us. So anyway, let's see how that might work. So to do, we need to do add to set. I think this is how this works. So this should add to set, and what we're interested in this case should be student ID. So. All right, so I don't know if I did this correctly, but maybe not. So we have 3 open curly brackets and 3 closed. So let's see if it's going to work. And in fact, it did work. So I must have had it correctly. So like I said, we are grouping over gender, and we're creating this group where we are selecting the student ID of the elements of the gender group, right? So let's play this and run this again so that it's the first thing on the screen. Okay. So one thing to notice about this command is that there is this semantics where the underscore ID references what you are creating the group over. We're creating a group over gender, and you could select whatever attributes you would like to see, right? For me, I selected the student ID. I want to see the student ID, but you could also, maybe you want to see the height. Maybe that's what you're interested in. You know, maybe it's the height in centimeters. And if that's it, then this is what you would put here, height in centimeters. And you can see that now I have a group over gender, and you can see the distribution of the height and in centimeters, if you will. So one of the beauty, of course, of MongoDB is that you can do this, right? You can see a distribution of whatever attributes you have over another attribute. So like in SQL, most of the time we count. It's hard to do this, right? It's hard to see how that an attribute distributes over the other. So most of the time you're counting how many. You're doing frequency. And just to clarify, let's go and do something like that in SQL. So imagine that I select gender and count gender from students. And you execute this. Of course, we forgot the group by gender. If we execute this, you can see what we get. And we always have this frequency, if you will, in SQL. And there is always this count, and I could try to do the same thing, right? I could try to do, height. Let's see, it's called height in centimeters. So, of course, we will now see how height distributes over centimeters. sorry, over height in centimeters. Right? So, okay. There's a mistake here. Height in centimeters. All right, so now it works. So again, you can kind of see that really what we are seeing here is what's very easy to see, right? Based on the rectangular structure of SQL is how the gender distributes over height and the frequency. So we know that there is one female, there is two females who are who have 165 centimeters tall, right? And every other group is just one person, right? There's one female who is 161 centimeters tall, 170 centimeters, who is female, and male, 170 centimeters, and so on. My point is, when you're writing this group operation or this group instruction in SQL, you kind of just lean towards counting, right? And frequency, right? And you can do that as well, right? In MongoDB, you can change this from add to set to sum, and you would just, you would sum and you add one, and it would sum it up for you instead of adding to set. So but the advantage of kind of MongoDB over SQL in this kind of problem is that you can actually see the distribution, right? This is a distribution of height over gender. I can see how it distributes, whereas in SQL, you don't see it, you just see the frequency. You don't really see the distribution, if you will, right? I mean, yes, you are kind of seeing it because you can see female but it's kind of, I guess you can sort. So if you order by gender, send it something like this. So I guess you can see it now, right? In a way, if you order it by gender, you can see in some sense the distribution of height over gender, but it's not as easy as this. This is just very easy to see how it distributes. This one, you have to sort it. And because I'm sorting it over gender, the male comes first and the female. And if the data gets really large, then it's not as easy to see, but I suppose you can export the data somewhere else. Whereas in MongoDB, this just gives you an array that you can import into JavaScript. I mean, things are more, in my opinion, more intuitive, right? And you could, you could do, I suppose you could, let's see if here, I think sum would just work. I don't remember if, right, we can just maybe sum this, see, and in fact, you see that this is precisely, so this is how you would do the regular counting. This is what SQL does for us, right? So, instead of student group, I could change it to frequency, and it would work nicely. Right, so, and here we go. So, male, there is only one male and there is two females, right? So if you want to just count, you can change add to sets to sum, and it will simply count it. If you want to see the distribution, you can just add to set whatever attribute you would like to see, right? Whatever attribute you'd like to see. And in fact, imagine that, what you'd like to see would be a distribution of the underscore ID. I mean, I don't know why, but object ID. Let's see. Oh, yeah, sorry. Of course, I forgot. You have to put the $sign, right? You have to put the $sign, and now it works, right? So, because this allows you to reference a particular field in your data, and you can see that I'm doing the same thing for gender. I put the $sign to reference the field. This is particularly important when you're in the aggregation pipeline and you're referencing fields in your data. You have to kind of prefix them with the $sign. Otherwise, it gets confusing. Even I was confused there. I was like, why is it not working? And yeah, you have to put the $sign. And if I went back to the original query here and change this to _ID, you can see as well that we have a distribution of the object ID. Yeah. So my point there is it's pretty easy outside of the fact that it's a bit difficult getting all the curly brackets open and closed, and yeah, so this could be a bit painful, but it also allows you to really learn the MongoDB aggregation API in a more intuitive way. And also that you know the things that that the things that are flexible. For example, you could call this anything, right? You can say student set. This is for you to determine by the attributes that you set, and these have operations in MongoDB, right? So, and you can see that if I run that, the only thing that would change is that my result now has this, right? And so let's go right ahead and change _ID to maybe a primary field. So yeah, outside of that one, everything else is fine. But by convention, this one must be _ID because it uses it to accumulate the result set. So yeah, so the _ID is, like I said before, is convention. This is completely whatever you want it to be because this is how you want to see your result. Yeah, and the attributes themselves, you prefix them with the $sign, and then you reference whatever you have in your data set, and it just works. So I feel like what else should we do? Let's go back and essentially sum. Let's sum this, and we'll call this frequency so that we have precisely what we have in SQL. And when you sum, you don't need to specify a field. So again, it doesn't have to be 1. You can sum with 10, and I will show you what that means. So you can see now that for every occurrence, it provides 10, and since female has 2, then it's 20, so it's a multiplier. So you can sum, you can give it any value. You can sum with 1,000, and it will use this to multiply the amount of data that you have in the group, and that's what you would get. So you don't have to necessarily add 1. You can add 10 as well, if you will. So that's another flexibility in MongoDB is you can sum based on and you can use any increment you want, right? So 10, 1,000, 20, 21, whatever increment you choose, you can use in your sum if you're just counting the elements in the group, right? All right, so is it now possible for us to maybe chain this group to something else? Could we do that? Could we chain the group to something else? Well, let's try to do that. So let's try to project, and then we group. Okay, so we will begin with a projection, and then we would execute our group on top. So this would be $project. And in this projection, we would include gender, since we're going to be using it. And that's it. We will include gender. Let's see if our query works. So of course, that query is not correct. Why? Because our projection is invalid. We did not turn on gender. It should now it's good. Now let's see if it works. And in fact, our query works, right? As expected. Our query works as expected. So let's see if we could limit. If we could limit and still group, could we limit and still group and see what happens, right? So as an in-between move, we would execute a limit operation. So $limit, and we would limit, say, 2. And all of a sudden, you see that now we have a uniform response, meaning there are no males anymore, just females, right? Because of the limit, right? We're limiting by 2. So could we skip limit and group? Could we skip limit and group? So let's say our limit is 5, and we don't have 5 things there, but it should not fail, right? So let's could we skip? And in fact, you see that it worked really nicely, right? We skipped the first one, and we have an even distribution in whatever is left. And the beauty of this is you can specify a limit value that is bigger than the amount of data you have in the set, and it would work. And what happens if we skipped everything? Imagine that we skipped 1,000, and we don't have 1,000 data set. We don't have 1,000 data points in the data set, but let's see if the query fails or whether it works. And it's just empty. By the time you limit, you only want 5, but you skip 1,000, there is nothing left. And then the group operation has nothing to do. It's just empty set. But you can see that you have this empty set returned, and but the query doesn't fail, right? It acknowledges that your query syntax is correct, but over the data space that you've provided, there really isn't anything to return. Whereas if your query was bad, it would give you this red thing, right? For example, when we forgot the column 1, it would say, well, gender is not defined. What are you trying to do? Sometimes the error is not particularly helpful. This is a more semantic error, is because you can see that this is coming from the MongoDB server itself, unable to accumulate by this thing called primary field, because the way the code is written is always looking for this ID underscore by convention. So if you don't have it, right, and specify an attribute over which you want to create the groups, you would find that it doesn't work. So in fact, the point of this is to tell us what the aggregation pipeline should use as this underscore ID when it's trying to execute it, right? That is why you cannot change it to anything else. But the rest is completely of what you want to show, maybe frequency, maybe a set, and that you can call whatever you want. Just that this, by convention, is you setting the property that you are using to create the groups as the ID that the aggregator is going that the aggregator will use as the accumulator object, which is the point of this. All right, so this is kind of a good stopping point for the aggregation framework. You know that you can essentially group, skip, limit, project, and perform all of the operation. The only thing that I did not show would be how to filter. But actually, filter goes under the projection. There is an attribute here, and it works like in that way. So it's a bit complicated. If you want to see it, I can show you in the documentation. So the way it would work is under our $project, we have a series of items, collection of students like so, and then we can now do the filter, and then we can reference the items. And if you look at the way their data is structured, which we don't have, is they actually have something called items, which is an array collection, which we don't have. So, and they are referencing that, and then the filter is filtering over the array, right? So it really references items that are inside of an attribute. So it's a bit different from what we have. And so that's why I skipped it, because we don't have our data structured in this way. But whenever we attach a property that is an array, then we can filter it down with this filter, right? So in the past, there was a top level property called filter, but that's no longer supported. So you can filter down on the level of the attributes, meaning what I mean by that is at this level, imagine that we wanted to attach an array. Maybe student has friends. Let's do that really quickly. So db.students.update1, and then we match. We match based on student ID. And then we would set and we send the attribute friends to be equal to an array like so. Let's see if I closed every and this would work. So if I now do db.students.find, db.students.find, you would see that now I have an array of friends. And now when I project and I select this friends, which is a collection, then I can filter over this. So this is what's now supported, as you can see from the definition of how it goes. This is what we now have supported. All right, so this is where we're going to be stopping for today, and I will see you guys next week. And as usual, I will post the homework, and it's going to be due at the usual time next week. So all right, do you have any questions before we go? No questions. So see you guys next time.